3 quarks for muster mark. This bizarre nonsensical line from confusing 1939 fiction novel is the exact reason why the fundamental building blocks of all matter in our universe have such a ridiculous name. Hi, I am Ruturaj Kulkarni and this is episode 14 of the Nobel Minute, a daily series we have where every day we do a quick deep dive of a topic of physics by choosing a year at random. With that, let's spin the wheel. I see it's landed on 1969. So today, we are looking at the prize awarded to Murray Gell-Mann. By the mid-20th century, particle physics was an absolute chaos. Scientists were using massive new particle accelerators to smash atoms together, and out flew hundreds of weird, unexplained subatomic particles. It was happening so fast that physicists jokingly called it the particle zoo, and nobody knew how they all fit together. Enter Murray Gell-Mann. He realized that if you looked at these particles through the lens of advanced mathematics, you could actually sort them into neat geometric groups based on their properties. Because the particles grew beautifully into sets of 8, Gell-Mann jokingly named his system the Eightfold Way, a cheeky nod to the Buddhist path to enlightenment. The system worked so perfectly that there was a glaring empty slot in one of his geometric shapes. But Gell-Mann boldly predicted that a completely undiscovered particle, the omega minus, had to exist just to fill that empty space. When experimentalists actually found it a few years later, exactly where he said it would be, it was proved that his blueprint was real. He realized these particles weren't fundamental elements at all. They were made of even smaller fractional components. And because he was a passionate student of linguistics, he refused to give them a boring name. He pulled the word quark from a James Joyce novel, forever branding the foundation of reality with a piece of classic literature. And here's today's fun fact. Gell-Mann was a notorious perfectionist and an extreme elitist when it came to language. He would openly interrupt his colleagues' physics presentations not to correct their math, but to loudly correct their pronunciation of foreign names or city origins. He even insisted on pronouncing his own colleagues' names with their original native accents, whether they liked it or not. He tamed the chaos of the quantum world with a bit of geometry and literature. And with that, I'll see you all tomorrow for the next episode of the Nobel Minute.